Okay, so thank you to everyone that joined. I'm glad to see new faces today. So what we'll be doing is we'll be looking at machine learning, and then we'll also see how to solve a classification problem. So these courses, we've been doing it since January, and then today is supposed to be the last class. We might also share the things we've done before with the group so that we'll all see what we've done. I'll be sharing my screen. I'll be sharing my screen in just a moment. I have a lot of open screens. Okay. So I hope we can all see my screen.
Yes, ma'am.
Okay. Yeah, great.
Yep.
So for those of us that attended the training I had with Yanditech that was sponsored by Yanditech, we saw this picture of first artificial intelligence being like the big circle and machine learning being a subset, deep learning even a smaller subset, and data science being like something like an overlap that's it overlaps with different fields. So simply when we talk about artificial intelligence, talk about giving the computer the ability to, in a way, think by itself, so not explicitly program. Now, in a normal computer science world, if you want to accomplish any operation, you have to write a code for it. So every single step you want to do, there has to be a code for it. But in AI, in machine learning, we want the computer to be able to figure out some things for itself. That means I shouldn't tell it every step. I want it to figure out things for itself using the data I give to it. So that's what differentiates machine learning or artificial intelligence from the traditional computer science. So here we have an introduction. So machine learning is a subfield of AI, like we saw from the screen there, that involves building algorithms and models that enable computers to learn from data and make predictions. So two things are very important here. You have algorithms and models that learn from data. We would also look at what models and algorithms are. But the main things you should know is that we want these computers to learn from data. Secondly, we want them to make decisions. So we refer to these decisions as predictions without being explicitly programmed. That means I should tell this computer, okay, I want you to differentiate between a cat and a dog, but I don't want to have to describe in its entirety what a cat or a dog looks like. But I want to give the computer images of dogs and cats, right? And have it differentiate between the both of them without writing a code for each and every step. So we see here that a regular computer program involves writing each and every step that is needed to complete a task. But machine learning works differently. We provide data such that the computer can learn by itself. So that's machine learning. So in other words, it's a way for computer to learn from data, to recognize patterns. So it's all about pattern recognition. How is a cat, for example, even when you have a child that is like 1 year old, 2 years old, the child can be able to differentiate between what a cat is and what a dog is. You don't have to start, giving that child rules about how a cat looks like or how a dog looks like, just merely looking at these things, that child is able to differentiate. So that's an aspect called computer vision. So it's like giving the computer eyes to see and then being able to differentiate between these two objects. Now, in machine learning, you hear a lot about models and algorithms, and actually they are used interchangeably. Sometimes you hear someone say models, sometimes you hear them in the same sentence, and then you're wondering what they mean. So most times they mean the same thing, right? But when you are exact, machine learning algorithms are tools and techniques that are used to learn from data. So mostly these algorithms are built on mathematical principles. There is some mathematics behind it. So those are the algorithms, right? Now, when we now learn and we have what we call representations, they are then referred to as the models. So this just, there could be other explanation for this, but like I said, models and algorithms are usually used interchangeably. So the machine learning algorithm are the rules used to learn patterns, while the models is like the output of the algorithms, right? So we can look at the algorithm as a recipe, right? And then we can then look at the model as the final product. So when I put all the recipes together, the dish is then the model, right? So the model is the output of the learning process. So we refer to this as learning. The whole, you see, when you hear machine learning, deep learning, so we refer to these processes as learning, right? So here we have an example. The algorithm for linear regression involves finding the line. So people that have done statistics or mathematics, they know about linear regression. So we find the line that fits a set of points. So the model that is produced by the linear regression algorithm is the equation of that line. So we know that there is a mathematical formula. So this equation can then be used to make predictions about the data, right? So the formula is like the algorithm. Then after we've used that formula on a problem, and then we have something like a representation of it, we can refer to it as a model. But like I said before, algorithms and models are mostly used interchangeably. Now, having heard a lot about machine learning, when do you use machine learning? Now, we use machine learning when you have to make repeated decisions, for example, and then especially when you have lots of data. So remember, I talked about linear regression as it has like a mathematical formula. So why do I then need linear regression? Why do I then need to do machine learning for a problem that could be solved using a mathematical formula? Now, sometimes data is so large, and then we refer to this in machine learning as being high dimensional. So you hear a lot about data being high dimensional, having many dimensions. So in such cases, being able to use a formula, you might not really get what you want. Not only that, so we have what we call training in machine learning, and then we have what we call testing. So we want a situation where we can generalize. By generalization, I mean that after I've solved my problem, my immediate problem, say I'm getting data from residents in Kaduna Central, and then later, say there are 100,000 people in Kaduna Central, maybe in the metropolis, and I gather data from them. So, say I use 50,000 data points from these people. Later on, I want to do something that involves the remaining 50,000 people. I don't want to always come and compute something new. So how about I use the information I got from the first 50,000 and then infer for the remaining 50,000. So that's when you typically use machine learning, right? So we use machine learning especially when we have large data that we want to understand, when there's something very complex, very difficult, you cannot be able to understand it. So you typically use machine learning to try to get an understanding of what it is. And then when you have labeled data, so for example, you go to the hospital and then you say you are sick. Now, what the doctor does is that the doctor would ask you question, okay, how do you feel? Do you have a headache? Do you have body pains? Blah, blah, blah. So what the doctor is trying to do is to collect data about your health condition. And then using that information, we'll be able to predict, okay, if someone has symptoms AAA, it means that this person probably has malaria. So the same thing for machine learning. The algorithm is trying to collect information and then trying to see how, for example, we could predict if someone has malaria. So I have a lot of data about people that have come to complain. So some of it, the doctor has labeled, this person has malaria, others, these people do not have malaria. How can I look at this data and be able to detect accurately? So without a doctor, how can I just put in data from people and be able to detect that someone has malaria, for example? So when I have labeled data, so we refer to that as supervised learning. We'll come to that very shortly. And then there's an unsupervised learning scenario where you don't have the data has been labeled. Okay, so these are the points when you typically use machine learning. So there are three main types of machine learning. So it's referred to as the supervised learning, unsupervised learning, and reinforcement learning. So most times what people do is supervised learning, but these days we are trying to move away from supervised learning to unsupervised learning. So what's supervised learning? Supervised learning means that I have data. So remember I gave the example about you going to the hospital and then the doctor asking you details about your health condition. And then based on the information you give to him or her, the doctor would say, okay, this person has malaria, or this person does not have malaria. So if we have information about someone or something, and then there is a label that is whether the person has malaria or the person does not have malaria, for example. Yeah, someone is trying to say something. Okay. So if, for example, we have information about someone and we have maybe the person has malaria or not. So that having malaria or not is the label, right? And that's referred to as supervised learning. Or it could be in the case of in the bank, you have you want to apply for a loan, and then when you want to apply for a loan, what do they normally do? They check your how you fared, right? In the past years. Is this person credit worthy? So usually they do some checks and all of that based on some of their principles, and they say, okay, this person is credit worthy, we can give him a loan. So when they label that this person can be given a loan, that's supervised learning. If the person cannot be given a loan, no, that's still supervised learning. So in that case, it could be like yes loan, no loan, right? So supervised learning involves training a model on a labeled data set where the correct inputs for a set of, the correct output for a set of inputs are already known. So we know what the correct answer is in a supervised learning. So what we are trying to do is to try to find a mapping from the inputs to the output. So people that have a bit of mathematical background will understand this, that we have a function and we want to see how can I map, or how can I draw a line, or the things we do in primary school, right? Where you have pictures of cats on the left and maybe the names on the right. So what do you try to do? You try to draw a line from the picture of the cat to the name cat, right? So this is also what we are trying to do in supervised learning. We are trying to learn a mapping. So how can I draw a line based on my data and then map it to the label? So if I have that a person has cough, catarrh, and maybe stooling, how do I draw a straight line to say, okay, this person has maybe sickness now, maybe malaria, right? So that's supervised learning. Now, unsupervised learning now comes, and then it's a case where you have you learn on unlabeled data set. So remember the first situation I gave, catarrh, cough, maybe stooling, and then we draw a line to say this person has malaria. Sorry, I'm not good with diseases. I'm not good with with okay. So you draw a map, right? To say maybe this person has diarrhea or something. Now, but what about if you don't have these labels to say someone has malaria or not? That's what is referred to as what? Unsupervised learning. So unsupervised learning is a situation where you do not have this map drawn from the data to something, right? Someone wants to say something. Okay. So when you don't have this straight line drawn or you don't have this map drawn, that's unsupervised learning. So in this case, we are trying to identify patterns and structure in the data. So this learning is often for tasks known as clustering and anomaly detection. So a typical example, banks do this a lot. So for example, they have a lot of data about people, and then they want to understand the characteristics of their customers. They could do an unsupervised learning, and then they'll be able to find their customers. Even on YouTube, for example, you find out that maybe you watch one movie and later on they bring movies of that nature similar to that, right? So although it's an aspect called recommendation, but still you could also look at it as an aspect of clustering, right? Then when we talk about reinforcement learning is it's a bit technical maybe. You have what you call an environment, and then you are trying to maximize the reward of an agent, right? So you might not even look at it until maybe in advanced machine learning classes. So what reinforcement learning does is that you train a model or you help a model to learn from its mistakes. So you have what we call an agent that tries to learn from its mistakes and then adjust its behavior based on the reward it gets from the environment. In this image we have here, we see the example I've been talking about. We have a dog here labeled as a dog. These are labeled as dogs and these are labeled as cats. So these are all labeled data. And then we are now trying to say, okay, the data should learn how to differentiate between dogs and cats maybe. Then we have unlabeled data. So they don't label it. They don't tell the computer this is a dog or this is a cat. We are now saying, okay, computer, look at this thing and tell me if this is a cat or this is a dog. That's unsupervised learning. So these two are supervised while these two are unsupervised, right? So you can even see this. We are now trying to look at the weights. How can I detect the weight of maybe an animal, a dog or a cat, based on how they look like, right? Yeah. So that's that on the main types of machine learning. Does anyone have any question? Any questions from anybody? Okay, no question. So
Sorry,
when we talk about,
sorry,
okay, someone go ahead.
sorry for putting short. I was trying to. Please, can you hear me?
Yeah, I can hear you.
Okay, I was trying to uh, unmute my phone. That was why I took too long.
Okay.
The question I want to ask is
Mm.
machine learning.
Yes.
People that doesn't have a root in mathematics, like have a more deeper root or understanding of mathematics, because
Mm.
at the time when you were talking about linear something and the likes, then this one is not a mathematical calculation. People that doesn't have much root in mathematics, this thing, can they also probably I'm not going to be sidelined in understanding this machine learning everything.
Yeah, so machine learning, it's good to have some mathematical background, but it's not like it's necessary, right? So you just understand the concepts, right? And then you are good to go. So maybe if you want to go for advanced machine learning classes, then you could actually go in for the mathematics. But yes, you could do machine learning without mathematics.
Okay.
Okay. Yeah.
I
Any
was
other
just
question? Abdulrahman wants to ask a question.
No, I don't have any question.
Okay. Great. So coming down to supervised learning. So remember I talked about supervised learning as being you have labeled data and then you want to predict what that labeled data is. So in this case, this problem where you have to predict whether a dog or a cat is referred to as a classification problem, right? Now, in a case like this, where you want to predict the weights, this would be a regression, right? So regression and classification are two subcategories of supervised learning. When we talk about regression, it involves prediction of a continuous output variable. So when I say continuous output, it means numbers like, how do I put it? Numbers that like 1.2, 1.3, things that have decimal points or may not have decimal points. But when you talk about classification, it's like you're predicting a yes or a no, a cat or a dog. Or in the case of a multi-classification, you're predicting maybe a cat, a dog, a rat, But these ones are each in a labeled data sense, in a classification sense, you have categories, right? But when you talk about a regression, you are trying to predict a number, usually a continuous variable, right? So examples, predicting the price of a house based on features. Now, you see the way the world is going, we are trying to do things without involving a lot of people. So maybe I have houses in an area. In Traditionally, you need maybe is it an estate surveyor now to be able to say, okay, this house is valued at maybe 1 million naira or 10 million naira. Now, what machine learning is trying to do is to get the information for the past 10 years or for the past donkey years. Estate surveyors have been predicting cost price of houses based on some heuristics. So what we are then trying to do is to say, okay, these estate surveyors have been able to predict the cost price of houses based on some features they see, maybe the location, the how large the house is, how the environment is. Why don't we collect all the data they've used to make such decisions in the past, and then based on that, use it to then predict the cost price of current houses, right? So that's machine learning. Now, that problem, remember, you're predicting amount, money. So it could be different values. So that's a regression. You're predicting a continuous value. Now, this also then, things like this will help you to see that why it is important for you to learn machine learning. So in many traditional roles will be taken, because you're basically doing what a computer can do, and I don't need to pay a computer, I just need to tell the computer, okay, this is what I have information, this place is in Lekki, it is 2 hours drive from maybe the stadium or important place. Based on this, tell me how I should sell my house. So it means that, for example, an estate surveyor would lose his job because I could get a machine that would do it for me, and most probably without bias, right? So again, you predict. Another example is predicting temperature based on weather conditions. So how can I use the weather conditions of a place over a period of time to be able to tell the temperature of a particular day? That's regression. That's machine learning. Machine learning could do that. Now, so regression models are trained to learn the relationship between input features. So when I give an example of the place being in Lekki, and okay, someone is asking a question about model. So we talked about model before, and we said we differentiated between models and algorithms. So we said that we could look at a model as the outputs of an algorithm. So an algorithm, usually machine learning models are built on mathematical principles. For example, linear regression, you have a formula for linear regression. So when I use the linear regression to learn a problem or to learn about a problem, I then have a model. So when I learn, I have a result which I can apply to new cases. So that result I have is referred to as a model. So you can look at a model as the result of learning. Yes, that's what a model is. I hope I've been able to explain. But if you don't really understand, we'll be sharing the notebooks, this notebook. And then from the beginning of the class, I think I explained the difference between model and algorithm a little bit in-depthly. So model is the output of an algorithm. It's like your food. I've put in pepper, Maggi, everything. The complete dish, when I'm done, is the model, right? Okay, so we then have regression models in machine learning, linear regression, multiple linear regression. As you progress, you would see what these are, how to use them. So depending on your problem, you would actually use different models, right? Then when we talk about a classification, which has been what I've been talking most of the time, you have a categorical output variable. So note the difference between regression and classification. So for regression, you have a continuous output variable, which you could look at as a number, which could be any number, arbitrary number. And then when you talk about classification, you are referring to something categorical, a category, right? So it could be a dog, a cat, an elephant, anything in a specific category. So now in the case of we could actually reformulate a problem. So you see, in a regression sense, we are predicting how much the price of a house is. Then in classification, we can say, okay, would this house be expensive or cheap? You can see the difference. Regression, I'll predict how much the house costs. In classification, I'll say, would the house be cheap or expensive? In regression, I'll say, what is the temperature? Would it be 30 degrees? Would it be 40? Would it be 33.5? That's regression. Then in classification, I would ask myself, would it be hot or cold? So I hope with these examples, we are able to differentiate between a classification and then a regression problem. So we could be able to predict whether someone has a disease or not as well. A lot of things can be done with regression models or classification models, right? So we then have examples of classification models, logistic regression, decision tree, support vector machines. Now I'm just telling you this just for you to know them, but you don't need to know them immediately, like now. I'm just saying, I'm just telling you that if you see something like linear regression, know that you use it to predict a continuous variable. If I have a model like multiple linear regression, you use this to predict regression, a continuous variable, then this would be used to compute categorical variables. Any question? Okay, so since there is no question, the problem of today, which I would like us to look at, is breast cancer prediction. How can we be able to predict breast cancer given data? Now, there are important packages we use in machine learning. We have NumPy, Pandas, sklearn, Seaborn, Matplotlib. So these are it's probably not possible. It's probably not possible to do a machine learning problem without any of these packages. So the first thing in any machine learning problem is understanding the problem at hand. I think I gave this, there was an image I drew in a class I had some on Yanditech about the circle. It's a circle you iterate, go through, and then make sure you understand the problem and be able to solve it. So breast cancer prediction, what does it involve? Now, if, for example, you have a job to do and then you are told to, okay, I need to know how to predict breast cancer, for example. So as a machine learning practitioner, as a data scientist or a data machine learning engineer, the first thing to do is to understand the problem. That's the first thing to do, understand the problem. So what is breast cancer? So questions you begin to ask is like the what is it? What features do I need to predict, for example, to predict breast cancer? What are the things I need to look out for? So look out for, stuff like this. These are the starting points of solving a machine learning task. So if I'm given a problem like this, I would also need to ask myself, how do I get data? Because without data, you can't, in fact, the lifeline of machine learning is data. If you don't have data, you can't do anything, right? So it's even one of the reasons why machine learning it's like going very fast, because we have a lot of data. What do we do with this vast amount of data? So machine learning is now trying to make use of the data we have. So I've done quite a few things here. So when we talk about breast cancer, in this case, we are talking about whether you have a malignant tumor or a benign tumor. So when we talk about a malignant tumor, is also known as cancer. So it's a type of tumor that can invade and destroy nearby tissues and organs. So again, in understanding the problem, you have to understand it with respect to the data you have access to. So you may not have access to the data you want, so don't just go off looking for information. if, for example, you've been given data by people that want you to solve a problem. Yeah, someone wants to say something. Okay, so if you've been given data by the people that want you to solve a particular problem, the first thing you should try to do is to understand the data. Okay, what are the constituents of this data? How do I use this data to solve my problem? So, because data comes in different way. For example, in this breast cancer, the type of data I have are like what was it called now? Continuous, each of them are continuous variables. It's in a data frame, what we call a data frame. Now, but I could be given images to also just look at images of breasts and then be able to detect whether the breast is cancerous or not. So that's data. That means if I want to study what a problem I have to study it with respect to the data I have. So if after I study this problem and then I find, okay, I need better data, then I could request, or I need not better data in this case, maybe another type of data, I can request for it, right? But first of all, we start to study based on the data we have or we think we would have. Now, sklearn, like I said, is a very important library which we use in machine learning. I don't think you can do anything without sklearn in machine learning. So the first thing you do is that, and these breast cancer data sets, there are different ways to get them. Now I'm getting this breast cancer data set from sklearn.datasets. So sklearn has a data set module, and then I can be able to import breast cancer from it. So when I type in this, I'll run the code. So what this means is that I've been able to import this model from the sklearn library. Now, when I want to get this data, I would say data is equal to, remember I got this model from sklearn. I'll say maybe load breast cancer. And then when I run this, what I've done is that I've initialized the data. So now from the classes I've been teaching, I've said sometimes there are a lot of things to learn in machine learning and you can't actually remember all of them. If you are looking for a method that could be implemented based on maybe a module or something, since I've initialized this with data, I could just put 2 question marks and then I'll have the documentation. So you can see the document. I can see what I have here. So it's saying string form. So it's now telling me that this is the data. It's in an array of this nature. And when I go down, I see I have a target. So this in a dictionary actually. So you have a target and then you have data. Now again, assuming I don't know how to use it, in machine learning, you have to read a lot about documentation. So I can just go online, right? So when I go online, I could actually look for, I'll just type in, I don't know if we can see this, my second screen. Can you see the window I just opened now?
Yes.
Okay, yeah. So I could just say, remember that I imported this thing from sklearn datasets. So I could just come here and say sklearn. I could even copy the same, load this thing and say sklearn and enter. So this is the documentation about this data set. So we can see what we have here. It gives a description. It says there are 2 classes. So what we are trying to do is a classification problem. It now says sample per class. Remember I said that we have the malignant and the benign. So for the malignant class, there are 212 data points. From the benign, we have 357 data points. So the total sample is 569. The features, the dimensionality, that means the dimension of the data is 30. The features, real and positive, right? So it's now giving us information about that data. Now, it's now also telling us that, okay, this data can be downloaded from here again, right? Now, these are now telling us the parameters. What are the things I could actually do when I am using this sklearn.dataset.load breast cancer? I could get the data. So if I do data, I could actually get all of these, the feature names, the target names, blah, blah, blah. And most importantly, it gives me an example about how to use this. So if, for example, I know that I want to use this load breast data, but I don't know how to use it, I could just come over here and just copy the way it's being used. So you can see the way it's being used. Load, this was the initialization. This was how they got the targets of this value, this rows rather. This is how to get the target names. So when you see targets, what target names mean is the classes. It refers to the classes. So coming back here, they said to get the target, I just need to do data.target. To get the data itself, I just need to do data. So you can see it's put in a dictionary, right? So what I will now come here to do is that I will now try to get the data. So I'll do like they did. I'll do data.data. I remember one of my professor, he was saying that like mathematics is not difficult. You just have to follow the example. In fact, he was saying you don't even have to think. So sometimes in machine learning, don't think too much. You think, but don't think too much. What you just need to do, look at examples and see how you can use the example for your own problem. So you see what I did? I went here, I looked at the documentation, I saw how it was being used. I look at what I could actually do with it. So when I do data.data and I run this, you see, I have exactly, remember I started by doing this and then it gave me this. And I said, okay, there's a data here. So I just did exactly what I saw. You don't need to be too smart. You just need to be able to identify patterns and be able to follow it. So we say data.data. And then when I run this, I have the information. Now, this is what we refer to as a NumPy array. You can see it starting with array. So what this means is that the data of these people are in a NumPy array like this. So if I want to, usually in machine learning, we work with data frames, that is Pandas data frame. So I would like to convert this NumPy array to a data frame. What I'll do is that I'll do PD. So PD is short form of Pandas, but first of all, I need to import the library. So I'll say import Pandas as PD. So I run this code, and now I can come here, I'll say pd.data frame. So what I'm trying to do is like a conversion, the way you convert something from one form to another. You convert a doc file to a PDF file. That's what I'm trying to do. So I'll say pd.data frame, data.data. So when I run this, now what do you see? You can see it's in a table. So a data frame is like a table, right? Now, but these things, they should have names. What is 23? What is 24? What is 25? Now, again, I'll come down, right? I'll go back to my documentation. Now, so you see what they said here, data, targets, feature names. So these are the names of the data set columns, right? Now, I'll go back here. Remember, this is feature names here. In fact, let me just copy. Data scientists do a lot of copying and pasting, by the way. So I can just come here and say that dot control V feature names and run this. So when I run this, these are now the names of the columns, right? So all these columns here you have 0, 1, 2, 3, 4, 5. These are their names. Now, what I'll try to do is that I'll try to replace these names, these numbers with these names. So how do I do it? Again, I'll do pd.data frame. In fact, let me not be like a hero. Let me just go back here and copy this and come here and paste it. Now remember that these are the names. I'll just put a comma and say columns equal to, then I'll bring this data.feature names here. So one thing you need to know again about machine learning is that you do things little by little. I do a small part of it, then I'll bring everything I've done together. So don't try to, if you have a problem, you want to be a superhero, and then you want to just do everything at a time. No, you do it incrementally. You see, I started by doing one part, data.data, where I got it in a data frame. Then I got the feature names. Now I'm putting the data and the feature names together. So now, if I want to be able to use this again, I have to give it a variable, so df. Now, a way to check, usually we like to check the first 5 rows, which is df.head. So this gives me the first 5 rows of my data frame. Good. So now, this is what I've been talking about as my features. The headache, the stooling, the vomiting, whatever, these are the features. Now, I need to find the target. That is, whether this person has malaria or not malaria. Now, I'll go back again to my documentation. So you see, I've made use of feature names, which I used to get the columns. Now look at it, target names, right? So again, being a good data scientist, I'll copy target names, come back here again and say, like I said, we do things incrementally. Then I'll say data. Why I'm calling this data is because I initialized everything. I loaded this data using the word data from here. From this data, I call to load breast cancer. So everything I have to do will be built on this. So again, I write data, then what I just copy, target names. So I'll run this. Now you see, the target names are malignant and benign. Now, I now know that I have 2 classes, but what I'm trying to do is to put against each feature, against each row, whether it is malignant or benign. I'll go back again. Now, we see we have dot targets, right? So this is the target name, the names of target classes. So this is the target itself, which is the values of each row. So I'll come back here again and put data dot targets. And then I'll run this. Now you can see, what do I have here? Zeros and ones. Now, the question then is, what is zeros? Do zeros represent malignant or benign, or 1 is malignant or benign? Now, almost everything you need to know about the data is usually in the documentation. I'll go back to the documentation. Now, from the documentation, it tells me that there are 212 malignant cases and 357 benign cases. Now I'll go back here again. How do I count the number of malignant and the number of, how do I count the number of zeros? Because if I know the number of zeros and ones, I may be able to know which is malignant and which is benign. So again, like I did before, I'll come back, I'll copy this row, I'll come back to here, I'll make it a data frame and say pd.data frame, and then I'll put it this way and I'll run this code. Okay, I missed an E, pd.data frame. Now, so usually you give this, so this one is usually referred to as your X, right? The features are usually referred to as your X. So let me rename this to X. It's not as if writing the F is wrong, just saying, let me try to be conventional. And then this one is usually referred to as your Y. So I'll say it's equal to this. And my column, just like I did before, this one is referred to as target. You can call it target, you can call it label, anything you want. And just like I did before, I will do Y.head to see the first 5 rows. Okay. Now remember, what did I want to do? I want to know which one, what 0 and what 1 stands for. So in pandas, there is a method called value count. So I'll say PD or Y dot value count Y. Then I'll put the name of the column. The name of the column is target. I'll say target dot value count. And run this. Now, what do you see? 1 is 357, 0 is 212. So let me come back to here. 212 is malignant. So I'll come back here so that I wouldn't forget. I'll write it down. 212 is malignant. Okay, let me be sure. Yes, 212 is malignant. So what it means is that 0 is malignant. So 0 is sick and 1 is benign. Simple, which is what I've done. So this method is just a way of understanding your data. So what I've been trying to do so far is to understand my data, right? Now, coming to the modeling, there are a lot of things to be done, right? But I'm just trying to give you the bare minimal needed for you to do a sort of machine learning. And from here, you can build to things that are unimaginable. Like you could do very special things, very sweet things, and then you'll be surprised, like, am I the one doing it? So I'm just giving you like an understanding of what the machine learning process is. Now, remember I started by saying that this is my X, the features. So this is my stooling, vomiting, blah, blah, blah symptoms. And then this target is now this person is sick or not sick. Okay, now, remember I also talked about collecting data. For example, I have 100,000 people. Then I take only a part of that 100,000 people, not everybody. And then I try to be able to predict. I want to be able to, so machine learning is prediction. I don't want to say everybody, I take a sample. And from that sample, I take a subsample again, that is a small part of that sample. And then from there, that small part of that sample is referred to as your training data. You have the X-train. So if, for example, I go to a village and I collect 100,000 data, now I have to train. Train means teaching for the machine learning model to learn. And I would say, okay, I have 100,000. Why not learn with 80,000? This is your train sets. Sometimes we divide into train, validation, and test sets and test. So the train is what the computer sees and learns from it. The computer learns from this one. Then the validation is the computer is trying to like, okay, am I getting things right? So these words you use to evaluate, am I getting things right? So this like evaluation, you use this to evaluate your model. And usually if I have 100,000, I take 80,000 for training. I can decide to take 10,000 for my validation. So this one, the computer does not see, right? So when I use the word see, it's not really see like see, but it's, I don't know, I've forgotten the right word to use. Then the test, this one, it's now like you are taking these parts, or let's say that this is the parts that you, what we call deploy. That is, you want to deploy it in a way, and then you test on it. So in a way, but most times how do I put it now? So let's just look at it as the computer does not see it as well. So we can evaluate on the validation and evaluate on the test. But in a real life situation, you can't really evaluate on the test because you don't have the labels. But in this case, we have everything. So we are like in a real life, in a is it utopia now? We are like in an ideal world, maybe, right? So it's already time, but I just want to finish this quickly. Like I said, this is the last class, and I don't want to come back again to it. So, but what we'll be doing in this class is that we'll be dividing the data into just two parts. The data is very small, so it doesn't make sense dividing into three parts. And this is usually for data science beginners to understand. So there's a package in sklearn. That's why I said you can't do anything without sklearn, or you can actually, but it will be difficult. So there's a package in sklearn called train test splits. What it does is that it splits the data for you without you having to divide it yourself. So I will come here, like I always say, check your documentation. I'll copy this from sklearn, the data set, the model selection, import train test, please. Then I'll come here again. So always there's an example. There's always an example. So I'll copy this again. Now, what this one is doing is that it's taking my data and then it's splitting into you see, we have X train, X test. So the X train is what my computer is training on, what it's learning from, and the X test is what it's going to evaluate on. So this X train and Y train, so the Y train is the label for X train, and the Y test is the label for X test. So you see X here means our features, and remember our features is called X. Y is the label, so I've renamed it to Y. Then the test size, that means how large do you want your test to be? This test size is in percentage. Our data is small, so maybe I should decide to do it 0.2 or 0.1. And then this random state ensures that you get the same result all the time. If you don't put a random state, anytime you run this, you have a different answer. So I'll run this. Now, remember from the beginning, I talked about different classification models. I said we have the logistic regression, we have decision trees, we have support vector machines. There are a lot of them. Now, in what we'll be doing today, we'll be looking at logistic regression. Again, I'll go back to sklearn, and then I'll say sklearn logistic regression here. So up here. Now, again, I'll go back to my example. So sometimes you can skip, just go back to the example. You can see from sklearn, you have to import the package before you'll be able to use it. That's why you see that I always copy this line. So I'll say, import this, bring it over here. Don't think too much, at least for now. Import your logistic regression. I'll go to my example. You see, this one is loading the data. We've loaded the data. We have our X and Y already. So I'll just come over here and copy. Control C, come back here. So I have to run this first, come back here and predict. So this is my CLF. What this means is a classifier. And then I want to predict. Now, so what is happening here is that I'm initializing here. So let me take this off. I'm initializing here. Remember that we imported the module. So I'm initializing and I'm putting a random state. Remember I said that the random state is to ensure that we can be able to reproduce the result. So after initializing, the next thing to do is to fit the model. So I will then bring this and fit. So fit is like you are making it learn the data. But I'm not going to fit on X and Y. Remember, I splitted my data into X train, X test, blah, blah, blah. So I'm going to fit on X train. If you fit on X and Y, it means you are making the computer to see everything you have. And remember that if it sees everything you have, it hasn't learned anything. It has learned, you will not be able to evaluate it because it has seen everything. So I'll fit on X train and Y train. Now, so this is, immediately I run this, as it has finished like this, it means it has finished learning, right? Immediately it stops. Now I want to predict. Remember now, I'm that doctor that have been giving, what's it called now? Symptoms, and I want to say, okay, what does this patient have? So now what am I predicting? I'm predicting X tests. So this is where I'm predicting. So I'll name this as Y predicts, and I'll say equal to, and then I'll run this. So it has now predicted the new people that were brought to him to be able to say, okay, is this person malignant, or does this person have cancer or tumorous cells or not? Now, this is why predict. Next, after prediction, how good was this model able to learn? So how good is this my logistic regression? Now, this now brings us to the evaluation. So in the evaluation, there are different metrics for evaluation. So one metric for evaluation is accuracy score. I'll come back here, I'll just write SK learn accuracy score. So accuracy score, you can actually implement it yourself. Accuracy score is that it counts how many models or how many examples the computer got right. So again, I'll just come here from sklearn.metrics, import accuracy score. I'll paste this, run this, then come here again, look at my example. So you see the way it is written, accuracy score, Y true, Y pred. I'll copy this, come back here. The most important thing to remember is that you will change the names according to how they are in your own example, in your own use case. So in our own use case, our Y true here is our Y test. So I'll copy this, I'll put Y test. And my Y pred here is this Y prediction. So I'll put it here, then I'll run this. Now what it says is that this computer got this thing 96%, it was correct. That's what this means. So 96% it was correct. Now this is one metric, accuracy. Now there are other accuracy, other metrics, but we are not going to look at that. We have the F1 score, we have precision, we have recall, and so on. But for now, we'll stop at accuracy score. Now, its visualization is good. There's what we call confusion matrix. So again, sklearn confusion matrix. So what does confusion matrix do? Confusion matrix help you to see pictorially where the computer go wrong. So I'll say sklearn computer and confusion matrix. So I'll come here again, like I always do, copy the package, Control C, come back here, paste it, run it, go back, check my example, confusion matrix, Y true, Y pred, copy this, come back here, paste it. So my own use case is Y test. So I'll change this to Y test and Y pred. Control V, yeah. So I'll run this. Now what it means is that on the diagonal, so the diagonal shows the number of correct answers. So it means, so let me plot it in a picture form. So we have what we'll call a heat map. So a heat map helps you to see this thing even clearly. So usually we import it from Seaborn. I'll come back here, go back. Now what I'm trying to help you do is to learn how to do machine learning even by yourself. Like you don't need to worry or work yourself so hard. Like I'm trying to help you see how you can get information by yourself. Just go to Google, anything in your mind. So recently or some time ago, someone shared something that I found interesting. He said, you can ask Google anything. For example, how to cry. So just see how to cry. You see 6 physical tricks on how to cry. Yawn before you cry on cue. So anything you want to ask, you can ask. The same thing with my machine learning. I want to do a confusion metric. So I can say, I told you it's a heat map. So I'll say heat map confusion matrix. And then, so this is an example. Okay, this one is not working. Go to another one, how to plot. So Stack Overflow is usually very good. Now, you see, this is the way to go. sn.heatmap, blah, blah, blah. I'll copy this, come back here, paste it. But first of all, I have to import the library. So I'll say import Seaborn. So SN is short form for Seaborn. Import Seaborn as SNS. I would like to import it as SNS. Now, what is the FCM? I'll come back to this example. So we see that it is the data frame of the array that is this value. So I'll come back here. I'll now say, for me, it's this confusion matrix. So I'll say the FCM is equal to this, and then I'll run this. So this is my confusion matrix. Now you can see it more clearly. So you see for class 0, that is, remember what is our class 0? Class 0 is malignant. So for class 0, it got 2 wrong. That means it was supposed to be for class 0, but it said it was class 1. But it got all of class 1 correctly. So on the diagonal is all the correct answer. That is on this leading diagonal, while on this off diagonal are the things it got wrong. So that's what I have for today on machine learning for classification. We spent quite a while. Do we have any questions we would like to ask? So in conclusion, our machine learning model, which is, so our model here is a logistic regression model, has been able to classify whether a person has cancer or not with a 96% accuracy. That's just the conclusion we can get from here. And that's on its evaluation, it got only 2 cases wrong. So we can say that this classifier is a good classifier because the number of wrong cases is very low, right? So this is the end. Do we have any question?
Okay, good evening.
Good evening.
I think this is my, sorry, I may a little bit take it back. But this is my first time in this class. But
Okay.
if I may ask, what are the basic requirements for you to okay, we are talking about machine learning, okay. From what I've seen a lot of, it talks about machine learning, talking about a lot of algorithms, and from a little I know about algorithms step by step in which you a particular thing is being done or how to find about it.
Yes.
Now, looking at it now, you from the point you understand the role of a medical term, how to identify breast cancer and all of that. Okay. Now, okay, my question is at what field or what sector can machine language be applicable? And from what I've seen, you use a lot of methods, like will I said, in learning, like what a lot of codings, I love that. Okay, use method, and using methods, it depends on what you actually want to do. Okay, so what you've used now for breast cancer, like all the methods you use, the syntax you use in finding out all those data, is it in all cases or on all data given to you to kind of, is it applicable to all, or is there a particular method to which you use to analyze any given data given to you? That is number 2 part of my question. Number 1 is that what are the requirements for you to learn this data, the machine learning stuff? Like I can see a lot of codings and all of those things. Like, okay, what do you have to have as a qualification, or what do you need to know as a background for you to actually become more proficient or become efficient in learning all these stuff?
Okay. Okay, thank you. So first of all, there's a paradigm of machine learning referred to as no-code machine learning, where you don't even need to code anything. You just need to move things around and you've gotten the same, you'd achieve the same thing. So what you need is just an understanding of the flow of machine learning. So everything I did here that I wrote codes for them, you could actually do it without writing even one line of code. Nothing. You just move things, and then it's just like people that have done Corel Draw and then they have Canva. If you know how to use Corel Draw and then you're using Canva, you just see that Canva is just like you're basically doing nothing compared to when you're, for example, using Corel Draw. Even Canva is even more involved. So this paradigm of no-code AI, you can do a lot without writing one single line of code. So the requirement is an understanding of the machine learning process. What happens at each step? What are you supposed to do? That is what is necessary. So on your second question, you asked about, sorry, can you tell me again? Did
Okay,
I
my
answer your first question well? Do you understand?
yeah, I believe so. Okay, then
Okay.
the second question is that okay, now if I understand it very well,
Mm.
they you try to kind of like call it analyze or kind of to like or, thought about was taken from a breast cancer kind of.
Okay. Okay, now I remember. So you were asking where can this be applied? So it can be applied everywhere. And in fact, in places or in paradigms where it is not applied, people are looking for how to apply machine learning to it. So this process, there's just a standard. The standard is getting your data, understanding your data, splitting your data in such a way that the computer will learn from one and work on the other and like test on the other. That is the flow. That is the flow of any machine learning problem you can think about. Then depending on whether it's tabular data, like we've looked at, tabular data means this thing in table, or if you have images, which is like what we call computer vision problem. So depending on, then you then come to the specifics depending on the type of data you have. But the main flow is being able to get your data, split your data, right? And predict with it. That is the main flow. Then depending on the type of data you have, you can do all manner of things. And then in the application, I think it's applied almost everywhere. And even in fields or aspects where it's not currently being applied, they are looking for ways as to how to apply them. I hope I've answered your question.
Yes, thank you so much. And you
Okay.
made mention of
You said?
you just made mention of getting your data. So how do you generate data that you can actually make all of these
Okay.
do
So
you generate?
yeah. So there's data in a lot of places. Mostly you get them online. You just search. So for example, in this one, if for example, I need breast cancer data, if you can see my screen, I'll just say breast cancer data. Breast cancer data. And then you can see Kaggle data set. Like there are a lot of places you can get data from. So you just need to search. Like the way I search for how to cry, if you are looking for a problem and you don't know how to get the answer, just type in how to on Google. That's all. To a large extent, you get the information. There are a lot of ways to get data, right? So I think we'll come to a close. We've spent closely 1 hour, 30 minutes or 1 hour, 20 minutes. Thank you so much for everyone that joined today. I can see new faces. Um, I'll be sending in the link for this class in the groups that I posted to, and then we'll be having the graduation ceremony in 2 weeks. Everybody is invited to welcome. We'll have a top machine learning engineer He's going to share his story about how he got to machine learning, how he got into machine learning. And I believe that it will be helpful to us. Also, there will be a project. So if you want to get a certificate at the end, so you just complete the project and get the certificate. So thank you so much to everyone that joined. I'll be ending the class now. Have a great night rest. Goodbye.